We're at the very start of the pipeline. Stage 0, data, feeding stage 1, training. The assumption that bites everyone. You trained on data you didn't fully control. We'll trace how a handful of planted samples become a flaw in the weights that only shows up at inference, then stack the defenses that catch it before it ever trains. Data poisoning, corrupting the model before it ships. Defensive walkthrough. We show the attack flow so we can defend it. LLM04, poison the data, corrupt the model. Pipeline at a glance, S0 data, S1 train, model, S4 inference. Today's surface lives at the front, S0 and S1, where data becomes weights. Your model is only as trustworthy as its training data, and you didn't author all of it. Around the training set, draw a trust boundary. The attacker lives outside it, but can still reach in through the data pool. The attacker contributes poisoned samples into the training pool, a handful among many. Flow only, never a recipe. The point: a few mislabeled rows from an untrusted source land in the same bucket as your benign data. Training can't tell planted samples from real ones. It learns the flaw straight into the weights, where no code review and no static analysis will ever find it. Hold here for the imported feature space clip, the poisoned cluster pulling the decision boundary off true. The reframe segment owns the screen. The pipeline view returns next. Months later, a perfectly normal input arrives at inference and lands on the wrong side of the now bent boundary. The corruption was dormant in the weights the whole time. No live exploit needed. This isn't only pre-training. A poisoned fine-tuned file or a poisoned RAG source corrupts behavior the same way. Same dashed red flow, same model, same wrong answers downstream. Layer 1, provenance and validation. Know where every sample came from, check its schema and labels, and reject the untrusted ones before they ever land in S0. The red dots hit the gate and bounce. Layer 2, sign the dataset, verify the signature at load time. A clean signed batch passes through. A tampered or unsigned batch fails verification and is rejected before training ever starts. Second beat, the green shield detector circling the poisoned cluster as outliers, and the decision boundary springing back straight. The imported clip owns the screen. We return to the pipeline. Layer 3, monitor training itself. Per slice loss and metrics. When a poisoned slice misbehaves, it spikes and the training monitor trips an alarm. Provenance, signing, and anomaly detection are the 3 green gates. S0 and S1 now wear green gates. The red marks are dimmed. Poison the data, corrupt the model, defend at the source. Next, O202, fool a finished model, live with one perturbed input. Break it on the board, not in prod. Defensive attack flow shown to defend it. Break it on the board, not in prod. Data poisoning is an integrity attack. Corrupt the training set, and you corrupt the model with no bad code defined. Remember, your fine-tuned data and your RAG store are training data too. You contain it with provenance, signing, outlier detection, and training time monitoring. None alone, all together. Next, forget the training set. We fool a finished model live with a single tweaked input. Break it on the board, not in prod.